Imagine you're traveling to a new city, you open ChatGPT and ask, find restaurants which are near me, serves Indian food, and are open right now. Sounds simple, right? But here's the problem. LLM doesn't really have data on your precise location and hence might not be able to come up with restaurants which are nearby. And it definitely won't have data on if the restaurant is open right now or not. Even though AI understands your question perfectly, it really doesn't have access to the tools needed to answer it. And this is exactly where MCP comes into picture. MCP is a standard way for AI assistants to discover and use external tools, making it possible for AI to go beyond just generating text to actually interacting with real world systems. In this video, we'll understand what MCP is. We'll take a look at its architecture and understand how MCP host, client, and server all work together. And to make it all concrete, I'll walk you through a demo for creating a restaurant finder MCP server, which can be used by travelers for finding restaurants based on their dietary preferences, location, etc. So stay tuned, because by the end of this video, you'll not only understand MCP, you'll see it working in real world application. So let's first start by understanding what is MCP. MCP stands for Model Context Protocol. So it is basically a protocol for communication between AI applications with external applications or data sources. So whatever data or information you get from this external application call or data call, you use that to feed in the context to the models itself. Right. So for example, for a restaurant finder MCP, you'll get restaurants as the data from the MCP server call, and you will use that as context which is fed into the LLMs, and LLMs will then come up with the final answer to your actual question. Now that you understand what is MCP, let's take a look at MCP architecture, which contains three main components. One is the MCP host, second is the MCP client, which is a component of MCP host, and third is the MCP server. Okay, so we'll try to understand this with an analogy, and I'll use the restaurant analogy for this as well. So suppose you go to a restaurant and you want to order some food. So you are basically the customer who wants to get something done, and so you are equivalent to a MCP host here. Okay, then how do you order a food is you wait for the waiter, right? And waiter is basically the person who communicates or handles any communication between you and the chef, right? So waiter is basically the MCP client, and chef, who is actually doing all the cooking and getting everything ready for you, is the MCP server. Okay, so if I connect it back to the AI applications, then MCP host is any AI application like Claude Code, Claude Desktop, Codex, etc. And then each of these MCP hosts create MCP clients whenever it wants to connect to any MCP server, right? And this MCP client manages all the communication with the MCP server. So whenever you want to get any data, or you want to make a tool call for getting restaurants or finding the weather or anything, this MCP client is the one which invokes that tool call in the MCP server. MCP server gets all the data, returns it to MCP client, and that is how host has access to all of this data through MCP servers, right? Now there can be two different types of MCP servers. One is a local MCP server, which I'll be using to show you during the demo, and local MCP servers uses STDIO transport, and then there can be remote MCP servers which uses streamable HTTP transport. So local MCP servers might have just one single MCP client, whereas remote MCP servers might have multiple MCP clients. So now we know that there is MCP host which creates MCP client for each MCP servers, but now we need to understand how MCP client and server interact with each other in order to execute a tool or invoke a tool, or get all the tools that are available so that LLM can invoke that tool, right? So all of this we'll try to understand in these 4 steps. I have color coded these different steps because The steps that are in white basically happens the first time any MCP client tries to connect to a MCP server. Okay, so MCP client sends an initialization request, and if MCP server is available, it will send a 200 OK initialization response, and then MCP client asks for tool discovery. So this step is very important, because in this step basically MCP client is asking the MCP server what all tools are available that I can make a call to, right? And it responds with a tools list. So tools list basically contains name of the tool, description of the tool, etc. And why this is important is because based on this name and description, LLM will decide if it needs to make a tool call or not, right? So this thing is very important, and this happens the first time MCP client is connected to any MCP server. So now this third step executes when LLM takes a call or decides that okay, I need to invoke this tool and it resides in this MCP server. So MCP client goes to MCP server asking for executing that particular tool, right? So MCP client invokes this tool execution in MCP server. MCP server does whatever it wants in order to execute that tool and then sends a response back, right? Now coming to the fourth, which is the notifications, you can see that this fourth step is not initiated by MCP client. It is only initiated by MCP server, because this is basically information about any changes made to the tools list, right? So if there is any change made on the server side to the tools by addition of tools or deletion of tools or modification of existing tools, then any of those kind of notifications is sent to the MCP client, so that MCP client is, it doesn't have any stale data. So these are all the steps that happen. Now that we understand the basics of MCP, let's jump straight into building an MCP server, as I promised at the start of the video. So here I am trying to build a MCP server which gets you to find restaurants based on your dietary requirements, location preferences, etc. I'll also be demoing this at the end by integrating it with Codex app, but before that let's go through the code first. So this is the main entry point of the tool which will actually be invoked from the LLM, right? If you want to define an MCP tool, then you decorate it with this decorator at the rate mcp.tool. I have one more here which is find restaurants near me. The only difference between these two is that it sets the city as current location, which is then taken care in the main find restaurants method itself. When this tool is invoked, it has certain arguments that are passed based on the information it is able to extract from the prompt, like the dietary requirements, vegetarian, non-vegetarian, etc. Place types, whether you're looking for cafes, restaurants, bar, pubs, radius, in what radius you want the restaurants to be given to you, then limit if you want top 5, top 10, whatever, right? Then I've set this auto detect location flag as true. So if this is true, it will try to find your current location from IP address. If you don't want this feature, then you can just set it to false and continue. If the detected location is there, then it will try to find the latitude and longitude of the current location. If it is not there, then it will try to find the city from your prompt itself. If it's not there, then might ask you for providing the city or the location you are looking for. If it's there, then it will just make a call to this geocode city method and try to find the latitude and longitude by that. Then once it has all of this data, like the latitude, longitude and the radius you're looking in for the restaurants, it will make a call to this fetch places method, which is actually just making a call to this overpass URL, which is URL for requesting data from OpenStreetMaps, right? So this overpass URL basically returns data which looks something like this. So if you see, it has an elements array which has names of the restaurants, cuisine, website, opening hours, and all of the data related to the restaurant. So here I've just mentioned like one, but if there are n number of restaurants, all of those will be listed here. So this is just an example how the elements that is referred here looks like, and then this is basically looping through each of these elements and then trying to filter out based on the requirements that you have mentioned in your prompt. So if it does not matches the cuisine, then it will just jump to the other restaurants in the list, right? Otherwise it will keep going down. If it does not matches the price that you have mentioned, then again it will skip that restaurant altogether. So it should basically match all of these requirements, and then that will be appended to the result, and the result is then sorted based on the distance in kilometers from your location and given it back to you, right? So you can go through this code, and if you have any questions, please feel free to drop it in the comment section. Now let's jump into the most interesting part and see it in working state, right? So I am running this MCP server in my terminal. So now we go to Codex, and here in the Codex you go to the settings in order to configure your MCP server. So here you can see I have already configured this MCP server, but if you want to configure a new MCP server which is running on your system, you just click on add server, and if you have a local MCP server, you use the stdio, and if you have the remote MCP server, you use the streamable HTTP, and then you provide in command how to launch it, or and along with the arguments and name of the MCP server, right? So I've already added it here. I'll just go back and fire it with a query and see if it actually invokes the MCP server or not. So I'll say find vegetarian Thai restaurants near me. Okay, and so in the sources we can actually see how it got the result, right? So if it uses restaurant finder MCP server, it will list that here. So you can see it's saying that it's used travel restaurant finder, and that is how it's trying to find me the restaurants, right? So it says found 2 vegetarian friendly Thai restaurants near the auto detected location. Here's a note. This is actually coming from the code itself, where I have mentioned that this uses approximate location. So near me may be off if you are on the VPN or your IP routes only, right? So you can again play with the code, experiment with the code. You can add more functionalities to it. If you learned something from this video, then don't forget to hit like and subscribe to my channel. Thank you.